Hello everyone, my name is Javin Pathak. I am from HaxSecurity. Welcome to my brand new channel, HaxSecurity. This video is on about BGP, Border Gateway Routing Protocol. This skill is must to have for every network security engineer. Give me 60 minutes and I will make sure you will be confident enough on this topic. So let's get started. So first of all, introduction to BGP. What is BGP? BGP full form is Border Gateway Protocol. Why border gateway? Because this protocol is especially running on the perimeter of a network. Now, what I mean by perimeter? Perimeter, it means the border of a network. It means where your internet is terminating, or means your public network starts from. Okay. So we have seen two type of routing protocols. First is IGP and another was eGP. IGP is your internal gateway routing protocol and eGP is your external gateway routing protocol. In the IGP, OSPF, eIGRP, even ISIS, RIP version 1, RIP version 2 are there. And in the eGP, one and only one, we have BGP, which is Border Gateway Routing Protocol. Okay. So what is the difference between this? Like IGP is running in the internal network, while EGP is you can even run on internal as well. But if you want to connect two external entities, two different organizations, then EGP is required. It means BGP is required. So BGP is actually maintaining a separate routing table based on shortest AS path. AS means autonomous system that we are going to just see after this slide, and other attributes that we are going to learn in the upcoming sessions. Okay. But unlike the other routing protocol like OSPF and eIGRP, they actually calculate or they calculate the routing based on the bandwidth, based on the distance. Okay. Those are the metrics that they are considering. But BGP is actually calculating based on the shortest autonomous system path or on the other attributes. Okay. So this is the routing protocol, which is choice on the internet. Because as I mentioned, it is connecting two different organizations. It is used as an exterior routing protocol. Because of that, internet you cannot imagine without BGP. Okay. Okay. Again, it is an essential routing protocol on the internet, which is connecting different autonomous system. So let's understand the autonomous system. We have seen that OSPF works in an area basis where wherever you are trying to achieve communication within the same organizations or as a part of internal network, you are using a particular area, putting those devices in the same area, and they were able to communicate. Okay. Over here, not area, but autonomous system, which is a group of IP network under a single administrative domain. For an example, ISP is there or any enterprise network is there. Okay. Each autonomous system will be assigned with the unique number. Okay, that number can be between 1 to 65535. But why to give this such an autonomous system number? As I mentioned that this protocol is used to connect two different entities. For an example, Microsoft is there and Google is there. They want to talk with each other. Okay, their data center or their servers or wherever their headquarters is there, they are completely different in the other locations. So when they want to communicate, how they going to identify that who is Google and who is Microsoft? Okay, so that will be identified via this unique autonomous system number. This number that the organizations has to purchase from approved bodies like INA. Okay, they will give their number, and from that number, these organizations will be identified. Okay, Google has this autonomous system number. If Microsoft want to connect with it, I will make a BGP peering with that particular number, and then the communication will start. Okay, so sorry, one second. So let me just remove this first of all. Okay, so there are two type of autonomous system numbers are there. One is public, which is for ISPs, organizations with an external routing. These numbers can be between 1 to 64511. And private, which is for internal use within the organizations, that can be range from 64512 to 65535. Okay, now how it works, as I mentioned, there will be a 2 point will be there, like Microsoft or Google will be there. So when you make a peering between them two, okay, the router with which a BGP, whenever you are going to enable with it, it's called a speaker. And the one with which you are trying to make a peering, it's called a peer, or simple a remote end. So BGP is always between 2 point. Okay, you are enabling, this is the entire Microsoft network is there, and the router or any a layer 3 device which is connected with the internet, on which the BGP will be enabled. Okay, on which you are going to enable BGP and running the process. Okay, not every other devices in the network should have a BGP. So just keep in mind. So this is your point to point. Point to point. On this side also, there won't be any L3 device on which this routing protocol will be enabled. And then this will be, process will be running. Okay. So from Microsoft perspective, Google is its peer. From Google's perspective, Microsoft its BGP peer. And this connectivity also referred as a peering, BGP peering. Okay. So it's a path vector protocol. Again, it's a path vector protocol which is exchanging the routing information between different autonomous systems on the internet. So unlike this OSPF and BGP, which are used in a single network, BGP is for designing for scalability and policy-based routing between multiple networks. Okay. Now, why path vector? Because it is calculating the AS path. When a route, when any IP address is traveling from one autonomous system to another autonomous system, it may traverse from other autonomous system in between. They may act as a transparent AS path, which is just traversing or allowing that route to traverse from it. So when the route is received on the destination, it will check how many number of autonomous system it has traveled from. For an example, you're traveling from Mumbai to New York. Okay. You may have a layover, one at Dubai, another at maybe on a London, and then you are reaching to the New York. So you can say that I have traveled from Mumbai to New York, but I have two hopes. I got the two layover. After that, I reached to the New York. So same way, maybe you have other entities from which the route is traveling. Once it will be travels from that, automatically that AS number will be attached to that route. So at the destination, this device or this router will have that information, how many number of autonomous system this route has traveled from. Okay. So this is how the BGP works. Okay. There are two types of BGPs are there. One is iBGP. The neighbors, I mean the BGP peers are within the same autonomous system. While eBGP, which is external BGP, which is, the neighbors are in the different autonomous system. In this topology, if you are making the BGP peering between B, C, and D, which are a part of same autonomous system 200, this is referred as iBGP. In this one, if you are making the peering between A and B, it means they are part of different autonomous system. So it will be referred as eBGP. Now the question may arise, Nikhil, you said that internally OSPF will work. Why we require BGP? Again, this is a routing protocol. It has a feature that internally also you can create BGP peering between the same autonomous system. So it will allow the routing, but it is not preferred because BGP is, handling thousands of routes. Okay. And it's a very slow converged protocol, means its convergence time is very slow. When any update happen in the network, it takes time to update its database, while is OSPF, EIGRP, these are the internal routing protocols which are having good convergence speed. They can handle any update. For an example, any link failure will be there, or any router goes down. So they update its database very quickly that how we can reach each other fast. Okay. So this is the nothing but the benefit of having IGP over BGP in the internal network. Okay. So this is why iBGP is not preferred over the in the internal network. Even we have seen that OSPF has AD value 110 just now, and even iBGP has 200. If you're running both of them in a single network, always OSPF will be preferred. Why? Because it has a lower AD value than the iBGP. Okay. And maybe you have a question about eBGP, then the AD value of eBGP is 20. But it's a completely different because it's an external BGP. Okay. So again, this is the types of BGP, iBGP, and eBGP. Clear, first of all? So I'm going to go with the next lab setup. So very simple lab setup that I have created for our first BGP peering. So let me know if you are clear. Then I'm going to move ahead with the lab setup. Clear, okay?
Yes, Nikhil.
Great. Okay. So in the lab setup, simple lab is there. Microsoft and Google. We have just now taken the same example, okay? FA0 by 0, FA0 by 0. On this side, 10001, on this side, 10002. Assuming the Microsoft is in the 100 autonomous system number and Google is in 200 autonomous system. A very first thing, why I have kept this two IP address in the same subnet? Because BGP peers should be reachable to each other in order to form a peering. Okay? If they are unable to reach each other, BGP will not come up. In the actual world, okay, this IP addresses will be a public IP address because these two organizations will be connected via any MPLS or internet link. Okay, maybe in between there, let's say ISP is there, AT&T is there. Okay, so this is the router of Microsoft and this is the router of Google, that they are actually connected with the public network or WAN side. So this IP address will be your public IP address. So you are making this peering actually between two public IP address. In the practical lab, because they should be able to reach each other, I have kept these two IP addresses in the same subnet. Okay. Now, configuration wise, Microsoft side interface FA0 by 0 that we already have covered a lot of time. 10001. Okay. Over here, 10002 on Google. Router BGP 100. Router BGP 100. This command is enabling the BGP process on this device or in this router. This number is showing, it means it representing a local autonomous system number. Same over here, Google router BGP 200. It means this is the local autonomous system number of Google. Next command is neighbor 10002 remote AS 200. This is your remote side autonomous system number. Neighbor 10001 remote AS 100. This is again remote side. So it says that what it tells us, neighbor 10002. 10002, it's my peer or neighbor. And it is a part of remote autonomous system number 200. Remember, I have just mentioned that how they are going to identify with each other, that who is Google on the internet, who is Microsoft on the internet. They are identified via autonomous system number. Okay. You have to be specific with the IP address in the configuration, because we have seen in the static and the OSPF, we were defining the network advertisement with the entire subnet ID and its mask. Over here, you have to be specific with the IP address, that this is the IP address with which I am making the peering. I am making the connectivity. Okay. So simple commands are there. So let's go with the lab side. And the command to verify if the BGP is up or not, show IP BGP summary. Simple. Show IP BGP summary. Okay. So let's move on to the lab part. I have already created that topology. Okay, just need to start them. Okay, already configuration is ready with us. So just I'm going to configure first the Microsoft with and then Google with. Okay. Microsoft configured. Now it's time to do for the Google side. So this is on the left hand side, and let's put this on the right hand side. So you guys can easily differ. Okay. Command as I mentioned, show IP BGP summary. So you can see this. Microsoft has a neighbor which is 10.0.0.2. V4 means version 4. This is IP BGP version 4 for IPv4. AS200. Okay. So this is in the AS200 with which I have made a neighborship. Two message I sent, two message I received. Currently there is no table version. Any kind of update happen in the network and it has to update its routing information. Then this version will be incremented. Okay. This is even important. The down and up. It shows that the BGP is currently up and running from 40 seconds. This is continuously running. Okay, if I go ahead one more time with the same command, then it will show us 1 minute and 30 seconds is the BGP peer establishment type is there. Okay, and then if I run the same command on show IP BGP summary, yeah, I have a neighbor called 10.0.0.1, which is Microsoft IP address. It is in the autonomous system 100. Okay. My identifier means what IP address do I have is 10.0.0.2 and my local autonomous system number is 200. Okay. Currently table version 1 is there and it's up and running from 2 minutes and 15 seconds. Prefix received or state we are going to see later on. But this is a very simple configuration, a lab setup to turn up the peering between two devices. Okay, this is we have created an eBGP between Microsoft and Google because they are a part of different autonomous system number. One is 100 and another is in 200. Okay, now let's understand the network advertisement in the BGP. Okay, BGP is not just to make a peering between two devices. Okay, we have seen that the two devices, Microsoft and Google, in the earlier example, we made BGP peering up and establish a session between them. Okay, sessions means the BGP connectivity we have created. So network advertisement is actually referring the process of a router, which is actively sharing its network reachability information with the neighbor router. Okay, in the earlier example, Microsoft and Google, they do have their own data center in which a lot of devices and their network is there. But the one that Google should reach to their Microsoft routes or the Microsoft should reach Google, only those route will be exchanged between these two peers. So that is nothing but the network advertisement. We will learn that in the lab setup in the next slide. Okay. So this is the core function of BGP, which is allowing the efficient routing across different autonomous systems on the internet. Okay. Let's understand clearly with this lab setup. The same lab setup I'm going to use in order to explain this concept, network advertisement. Let's take the Microsoft has 1.1.1.1 a loopback interface and 2.2.2 is the loopback interface which is on the Google. This route is this route need to be reachable via Google, and 2.2 should be reachable via the Microsoft. Okay. Again, the agenda is Google should reach 1.1.1 and Microsoft reach 2.2.2 via BGP peers. Okay. First, let's understand how to configure the loopback. Okay. The way that you configure the IP addresses to the physical interface, same way you have to do it for the loopback. The loopback interface you can configure like this. First, interface loopback and the number of that loopback and the IP address. You don't need to admin up this loopback interface because it is always up and up. Till the router or your hardware is up, this loopback stay up with it. So on the Google side, I have configured 2.2.2 loopback 100, and on the Microsoft, I have configured 1.1.1 for the loopback 100. Okay. Now, with the network command, we are advertising this route in the BGP process. Okay. So router BGP 100, network 1.1.1 with its subnet mask. This is the command by which you are advertising this route to its peer. Okay. If you have multiple neighbors configured under this BGP configuration, then all the neighbor will have a visibility of this route. It means this network will be advertised to all those peers. So this is getting advertised to the Google. So Google can reach this 1.1.1 via next hop 10.0.0.1. Why? Because we made the peering with the neighbor IP address 10.0.0.1. Correct? On the other side, on the Google side, under the router BGP 200 process, network 2.2.2.2 with its subnet mask, we are advertising 2.2.2 network to its Microsoft peer. So I hope this is clear how to do network advertisement to the peer. So if you want to advertise any network to the BGP peer, you need to do it with the network command under the BGP process. The condition is the network that you are advertising, that network or route should be present into that routing, into that device routing table. Then and then it will be advertised to its peer. Why I have selected loopback? Because loopback is the directly connected interface for this local. Same way over here, this loopback is directly connected to the Google router. So that route is present into the routing table of Google so that this can be advertised to its neighbor. Okay. Because of this reason, I have created loopback. So it will be a part of routing, local routing table. Okay. So I hope this is clear, the network advertisement and the purpose of it. Okay. And in order to verify the command, how we can see the routes, command is show IP BGP. Show IP BGP will show you the routes which are present in the BGP routing table. Okay. If we run show IP route, then it will show you all the routes which is present into the routing table. It may include OSPF, it may include static, it may include the directly connected. Okay, but in the BGP, show IP BGP, only the routes which are related to the BGP, those will be visible. Okay, so let's go on to the lab part and verify BGP routing table. Okay, I have already turned on the lab, so let's see. So this is on the left hand side, Microsoft is there, and right hand side, Google is there. First of all, let me verify the BGP peering is up with the command show IP BGP summary. I can see that 10.0.0.2, which is the neighbor, a Google IP address that I have created the neighborship. It is up and running from 13 minutes and 14 seconds. Now, under the BGP process, first of all, let's create loopback IP address. Okay, we can verify if it is created via show IP interface brief. So I can see that loopback has been created and its status is up. Same way over here, interface loopback 100. IP address will be assigned as 2.2.2, 255, 255, 255, 255. Okay. Now let's do the network advertisement under the BGP routing process. So Microsoft is in local autonomous system number 100. In that one, I'm going to advertise the loopback interface IP address, which is 1.1.1.1 with the subnet mask. Same way on the Google side, router BGP 200. Network will be 2.2.2.2 with the mask. So configuration is completed. Let's verify the BGP routing table by show IP BGP. So you can see that Microsoft has a visibility of two routes. I mean these two routes are present in the BGP routing table. Okay, first one is 1.1.1, which is getting advertised by this router itself because this is a loopback interface. You see this next stop is 000. It means I'm not learning this route via anyone. I am advertising this route. Because of that, the next stop is 000. 2.2.2, which I am seeing that I am learning via 10.0.0.2. What is 10.0.0.2? 10.0.0.2 is the IP address of a neighbor of a Google. Okay. So I'm learning 2.2.2.2 via 10.0.0.2. So what is the next stop over here? 10.0.0.2. Okay. So this both the routes are a part of BGP routing table. Okay. If I ping 2.2.2, which is the loopback IP address of Google, I'm able to ping it. Same way if I go with the Google side and try to see the BGP routing table. So 1.1.1, I'm learning from Microsoft. My next stop IP is 10.0.0.1, from which I'm learning 2.2.2, which is the loopback IP address of my router. I'm not learning, but I'm advertising this route to my peers. So the next stop is 000. Okay. So I hope this is clear to everyone. This lab is to do network advertisement in the BGP routing table to its peer. Okay. See you in the next. Okay, guys, let's learn about the BGP attributes. Why BGP attributes are required in BGP. Okay. BGP is actually the backbone of internet routing, which enables different autonomous systems to exchange the routing information. So BGP attributes are essential because they help to control and influence routing decisions, which ensures the stability, efficiency, and policy enforcement. Okay. So it is influencing the inbound and outbound traffic using these attributes. The connections which are coming to the autonomous system or going out from the autonomous systems, we can influence both of them using these attributes. Okay. So with this, they are very essentials to control, and it help even to make some routing decisions which ensures the stability, efficiency, and policy enforcement. The key reason of to use this first is the past selections and the best route determination. BGP may receive multiple routes to the same destination. So attributes can help to determine the best path. Second is the traffic engineering and policy control. So organizations even can manipulate the attributes like MED, local preference, AS path prepend to control inbound connection to the autonomous system or going out connections from the autonomous system. Third is the loop prevention. The attributes like AS path, okay, which avoiding routing loops by ensuring a router does not accept a route containing its own AS number. Scalability and stability. Attributes like local preference allows ISP to prioritize internal routes over external ones, so which optimize the performance. Flexibility and the routing decision. Different networks can implement their own routing policies using attributes without affecting the LS. Okay. So let's know what are the attributes, types are there, and what are their names are. So there are two types of BGP attributes are there. One is well-known and another is optional. In the well-known, we have mandatory and discretionary. And in that, we have next stop is path origin and local preference is there. In the optional, we have transitive and non-transitive. In the transitive, we have aggregator and community. And in the non-transitive, we have multi-exit discriminator. Okay, so these are the attribute types are there, well-known and optional. And these are the name of it. Now, let's learn the AS path attribute. Okay, how it works. We have just now seen that it is used to prevent the loop in the network by ensuring a router does not accept a route containing its own AS number. Okay, so in this topology, we have R1, R2, R3, R4, and R5. Let's say R1 is in autonomous system 100, 200, 300, R4 is in 400, and R5 is in 500. We have one loopback interface, which is 1.1.1/32. And this is need to be advertised to the R4. Okay. This need to be advertised to be R4. It means the R4 should learn this route. R4 should learn this 1.1.1 from R1. If you see closely, then it has two paths to follow. One is it should go R1, R2, R3, and it reach to the R4, the blue one. And another is to go via R1, R5, and R5, the red one. But it will only choose the one. Either it will be R1, R2, R3, or R1, R5. Okay. It will choose the best one, which will be the shortest AS path. If you see this route is traversing from two autonomous system, which is 200 and 300, while on this side, it only has to traverse one autonomous system, which is 500. So this side 2 and this side 1. So 2 is greater than 1. When the R4 sees it in its routing table that I am receiving this 1.1.1 via two path, but it will choose the shortest one, which is the R5 one. Okay. So in the BGP routing table, you will see that it is preferring the R5. Okay, it is preferring the R5. The arrow, it indicates the best path or the preferred path the R4 is selecting. I am running this show IP BGP command on R4. So it is receiving 1.1.1 via two path 500, 300, 200. Okay, just to mention over here, this is 40.0.0.2, which is the neighbor IP address and the in this one, and the this side it has 30.0.0.1. So when comparing this both the one, this one has a lower or shortest AS path to traverse, and this one has the higher one. So it will choose the one. So because of that, the R4 will prefer to go on R1 via R5. Okay. So this is nothing but the AS path attribute, autonomous system path attribute. Now let's say if I want to make not R5 as my preferred path, but the R2 and R3. By algorithm, definitely when R4 receive this route, we can see that R5 it will refer because it is only traversing from the one autonomous system. But as a network engineer, sometimes it is required to switch or to manipulate the path in order to switch the path to the another side. Let's say your manager is saying that we have some issues on this path. I need you to route the traffic to the other side. That's where your attributes or some extra configuration is needed to do it over here. So let's understand first, and then we will go on to the lab portion. Okay. So by algorithm, when any route received on the R4, it is comparing both the path, that the one which has the lowest autonomous system number to traverse, it will always prefer. So if I make some extra configuration, it may look that this path has the higher number of autonomous system and this is the lowest one. We have already two autonomous system which is this route is traversing. So I need this one to be more than 2. So let's say 3 is greater than 2. So I need to add 2 extra autonomous system number. I'm going to add fake autonomous system number in this path by doing some extra configuration in the way that when R4 receive 1.1.1 in its routing table, this side it will show two more path along with the 500 and this side 200 and 300. So while comparing, this will have a 3 and this will have a 2. So 3 is greater than true. So this will be preferred. Okay. So what that extra configuration is there and what will be the result? Let's see in the lab portion. Okay. So this is the our topology. To save our time, I already configured every router. You can see this. Even I have abbreviated and assign the IP address with the proper port which we are going to use in the network. So everything is there. Okay, I just have to start it. I am on R4. Okay, I have a neighborship with the 30001 and 40002. Let me confirm it is up or not. Yeah, I have the neighborship with the 30001 and 40002. And these are up from last 45 seconds. So the neighborship is up. Now let's check the BGP routing table, show IP BGP. I should learn this route. Okay, you can see this. I'm learning 1.1.1, one from 30001. This is your 30001. Another is 40002, means the R5. So the below one is R5. You can see 500, 100 high. Above is R2, R3, which is 300, 200, and I. Clear? You can see the arrow is towards the R5 side. It means I'm learning this route from both the side, but my preferred path will be R5. Now I have to add fake autonomous system on this side. So this arrow will be shifted towards this side. So it will be preferred. Okay, that is my end goal. Now let's understand this, how to do it. I'm adding 900, 900 on this side. But where? Means to the route 1.1.1. So when 1.1.1 will come from R5 to R4, when 1.1.1 will be advertised from R5 to R4, this 900 should be attached to it. Correct? So it means your if and then statement will come over here. This is already you have done in the basic mathematics, even in the C language, even in the Excel file as well. Like if student having the percentage greater than 70, then I will mark those student they have a distinction. Correct? So if they are above 70%, then they have got a distinction. Correct? Same way over here it is there. When a route will go from R5 to R4. So if 1.1.1 will go from R5 to R4, then 900, 900 will be attached. Okay. Now in the configuration of these devices, this can be achieved with the help of route map. Okay, what it is? Route map. So now let's understand the configuration of route map. First of all, create a route map. This is the command and give a name because you have to use this name in the BGP configuration. We are first of all creating if and then statement. So if I'm going to give a name as path and then permit 10. Permit 10 means whatever lines I am adding after this will be permitted in the firewall or sorry in the router. And 10 is just a number, you can give any number, no mandatory. Now that there comes your if statement. If, okay, over here instead of if you have to use match. Match IP address. What is the IP address? We need to attach this 900, 900, 1.1.1.1, right? /32. If you see this IP address, it means when you see this IP address, set, this is your then statement. Okay. Then set AS path prepend. It means attach, prepend, append, attach, same thing is it. Then attach 900, 900. Simple. This is your if statement. If IP address matches 1.1.1, then append 900, 900 to it. Simple. Now this should be part of what? BGP configuration. So router BGP 500. So this configuration you have to add it on R5. Why? Because we need to influence the traffic on that side. Correct? Because when it goes from R5 to R4, because you have to do this configuration on R5. Router BGP 500. 500 is the local autonomous system number of R5. Already we have configured the neighbor, which is 40001. So I'm not explaining what it is. It is already up. Remote is 400. Remote is 400. Again, neighbor 40001. Attach the route map that you have created above. What is the name of it? AS path. Okay. And direction you have to mention out. Why out? Only two possibilities are there after it. In or out. From R5's perspective, whenever it sends the route 1.1.1, so it is going in the outgoing direction. Correct? It is going out of the autonomous system. Because of that, out. If you are doing this configuration on R4, then it will be in. Because 1.1.1 is incoming connection to the autonomous system. Getting my point? From R5 perspective, 1.1.1.1 is outgoing. It is going out from the autonomous system because out you have to mention. So only two possibilities, in or out. So you have to think from the perspective of a router on which you are configuring. Because it is going in the out direction, so it will be out. Only these steps are needed. So what I'm going to do is I'm going to add this configuration on R5. Okay. Config T. First of all, create a route map. Is path. Yeah. Permit 10. match IP address 1.1.1.1/32. Okay. Set ACE path prepend 900. Okay. If you want to verify the configuration, again, you can do like this way: show run pipe section route map. Okay, you can see this route map ACE path permit 10, set ACE path prepend 900. Okay, this is the section of route map. Now configuration of router BGP. Router BGP 500, neighbor 40.0.0.0.1. Attach the route map that you have created above. Name is ACE path and outgoing direction. Okay, done. Can we see this output on the R4? Remember, BGP is slow protocol, so it takes time to update it routing table. Okay, you can see this, it takes time. Currently it is receiving the one prefix from this one, and the table version is 2. We will wait more about 30 seconds. Can you see this now? 500, 900, and 100. Previously, it was not there. Previous, the arrow was towards 500 side. Now this arrow, it means the preferred path is now 300, 200, R2 and R3. Why? Because now when it is comparing this path, it says that these are the two autonomous system it is traveling from. Now these are the three. So 3 is greater than 2. Because of that, I'm going to prefer R2 and R3, not R5. Okay. I hope this is clear. Now the version of table is even incremented by 1 because we have changes done in the configuration. Previously 2 was there, now 3. So let's understand one more attribute, which is MED, multi-exit discriminator. Okay. So what it is, we have already seen this is an optional and non-transitive BGP attribute, which is used to influence the inbound traffic from an external autonomous system. Okay. Again, it is influencing the inbound traffic coming from the external autonomous system. Lower the MED values are preferred by the neighboring autonomous system. By default, the MED value is 0 for all the routes. Okay, until we set anything, it will be 0. So how it work? If there are multiple links exit between two AS, this attribute is actually choosing the preferred entry point by comparing the MED value. The lower is the one which is the preferred one. Okay, so only compare between the routes coming from the same autonomous system number. Okay, so this is the MED. Let's more understand this with the practical example. Okay, this will be our lab topology to understand more about the MED. Okay, let's understand the topology first. We have R1, we have R2, and we have R3. Okay, R1 and R3 both are in the same autonomous system number, which is 100. and R2 is in 200. We have a BGP neighborship between R1 and R2 and R2 and R3. This is the eBGP neighborship. Again, we have not created any iBGP neighborship between R1 and R3, even they are in the same autonomous system number. I have configured loopback 1.1.1 on both the autonomous system number, which is same, which is 1.1.1. Why? Because when I advertise this 1.1.1 from R1 and R3, R2 will receive first 1.1.1, the same route from both the side, and from the both same autonomous system number, which is 100. Okay. And we are going to compare the first MED value, and by default it is 0. So the one which it will choose, let's say it is choosing the R1, is it a preferred path? Then R2, whenever it ping 1.1.1.1, it will ping R1's loopback, not the R3. But by changing the MED value in a such a way that we are going to switch the preferred path from R1 to R3. Okay, that will be the our end goal. Okay, let's see the output. I have already configured R1 and R2 and R3. Okay. So first of all, I'm going to make sure the neighborship. So I have two neighbor, which is 10.0.0.1 and another is 192.168.1.3 from R2. Okay. So that is up from 8 minutes and 5 seconds. And let's see the BGP routing table by show IP BGP. So 1.1.1, I'm receiving from R3 and R1. And you can see the metric. This metric is nothing but the MED value, which is 0, 0 from the both the side. Currently, it is preferring the R1 side, which is 10.0.0.1 side. Okay. So if I ping 1.1.1, I am pinging the loopback IP address of R1. Okay. So I'm able to ping it. The preferred one is again the R1. Now I want to change to the R3. Okay. I want to change this with the R3 by doing configuration of MED value, by doing the changing the value of MED. Remember, when it compares the two route, the lower one, it will be preferred. Over here, the lower one is both the sides 0, 0. So if I want to make this as a preferred, the other side should be greater than 0 because this is already 0, right? If I want to make this as a preferred path, R3 as a preferred path, then I need this value to be greater than 0. So my arrow, my preferred path will be shifted from R1 to the R3. Okay, and that will be the our end goal. So let's see the extra configuration which we needed. Okay, we have already seen that in the AS path prepend as well. Same kind of configuration is there, but change in the MED value. Okay, so first, route map, set MED, give a name, permit 10. Okay, if and then statement. If is your match IP address 1.1.1.1/32, set metric it should be greater than 0. You can put anything. I'm going to put 50. Okay. Router BGP 100. Okay. Neighbor 10.0.0.2. This configuration should be done on R1 because we are increasing the value of metric MED value on the R1 side. Remote is, sorry, route map set MED outgoing direction. Okay, because the from the R1's perspective, this route is going to the R2, so into the outgoing direction. So let's do this configuration and verify the output on R2. So, okay, I forgot config T. So this is done. And on R2, show IP BGP command. BGP conversions time, any update in the network, it happens. It takes time to converge. Okay. We can see the table version is 2 currently. Once we see the changing in the metric value, we will even see the table version again. Okay, still not reflected. Okay, perfect. Now you can see the metric value is increased from 0 to 50. Okay, and the preferred path is now R3. So now when R2 compares 1.1.1 coming from R3 and R1, when it compares the metric value, MED value, one has 0 and another has 50. Lower one, it should be preferred. So it is preferring now 0. It means the R3 side. Previously both were 0. The arrow was shifted, means arrow was towards the R1 side. Now you can see it is to the R3 side. So this is how you are going to manipulate or route the direction of traffic using the metric value. Now you can see the table version also increased by 1. Previously it was 2 and now it is 3. Okay. Thank you.